Hi everyone. So this is our session 3 of a 6-part series where we are discussing about uh, Python for network engineers. So in our lesson 1, we talked about basics of Python, and then in lesson 2 about some of the data structures. In this session 3, we'll be discussing about uh, uh, in this session 3, we'll be discussing about files. Then we talk about few uh, file formats like JSON and YAML, right? And then about regex. Okay. But before going ahead with session 3, we'll discuss about the solution of the problem statement given in session 2, right? So this was our problem statement, right? We have given some raw output, right? And from this raw output, we want how many router interfaces, how many interfaces are up, down, which interfaces are down, their interface names, and how many unique IP addresses are assigned, right? All that data we wanted, right? So we wanted to use all the data structures and if possible functions, right, to do this activity, right? So let's talk about the solution. Okay. So this is our so what I've done is I've created this raw output, right, which I provided, right? So this raw output I have given in the uh, parse show IP interface, right? In this raw output is basically a dot strip, right? So it will give me a list, right? That I have passed into parse show IP interface brief, right? So parse show IP interface brief. Uh, this is my function, right? And uh, then I'm printing that data, right? And after printing that data, I am summarizing all the interfaces. I'm summarizing the interfaces data. So I have two functions, right? And one function is giving me the summary of one function is giving me parsing that data, and another function is summarizing, right? So that's how we are making this code modular, okay, using the functions. So first, this is a definition. This is the function name, right? And this is the parameter which I have passed, right? This is the string which represents what is the use of this function, right? Something. This is the just a comment, right? A documentation for documentation purpose. Then what I'm doing, I have lines, right? What I'm doing, I have raw text. I'm doing split lines, right? Split lines as in it will split that data, correct? Then I have header, right? The first line will be my header, and other lines I am putting it in data lines. Okay, so this is I'm unpacking the data, right? I have lines, so I'm first entry in that line will be header, other will be in data lines, right? And I have created for the output I've created a empty string, right? Then I'm saying for line in data lines, okay, for these lines, okay, what I will do is I will split that line first, okay. Then from there I will take the interface, IP address, the protocol, and the status, right? Then in the parsed I will append the interface name. This is a if you see here, this is a dictionary, right? So I'm putting the interface name, then I'm putting this is the key, this is the um, value, right? So we know that in dictionary it is a key value pair, right? So IP address, status, protocol. Then I'm saying is up. Okay. So is up, I'm doing status is equal to up and protocol is equal to up. Then I'm saying is up. Otherwise, it will be uh, false, right? So this is basically true or false. So is up is not a string. It is true or false data. So this shows that I can mix and match multiple types of data in a dictionary, right? So it is not to be like all strings only, right? This is a mixed match of data. Okay. Now I have printed that data right here. So I have got all the data, right? Interface is this, IP address is this, status is up is true, right? So here is up is true, here is up is false. Here again is up is true, is up is true, is up is true, right? That is my first function, okay, which took this raw text, right? And then for all our entries, I am just printing it, okay? And this is the return, right? Which return? So this return, the return passed. So this parsed got stored in this interfaces, right? And that interfaces, I am passing it here, right? In summarize interface, which is the report, right? Which will give us an output of report. Okay. Then I'm taking this interfaces data only and I'm putting it in summarized interfaces, right? And this interfaces data gets stored inside the function, it gets stored in past interfaces. Okay. So I am taking the total length of past interfaces, right? And here I am doing in the list, right? If I'm finding out if the interface is up, if the interface is down, right? This is basic using list comprehension, right? If this is up, then I'm saying up. If not is up, then I'm saying it's down, right? I of IP address for I in past interfaces. If I of IP address is not equal to assigned, that means if the IP address is not unassigned, then I will give it. I will have the IP address here, right? But if you see the IP address is in a set, right? So that means I will only get unique IP address. I will not get duplicate IP addresses. Okay. So here I have used list. Here I have used set for unique IP addresses. Here I used dictionary for a list of IP addresses, right? So all this I have used, right? And then I'm returning it in a form of a dictionary, right? So if you see here, the return was in a list, right? So I can from function, I can return any data type. I can return the list. Here I'm returning a dictionary where I'm saying total interfaces is total, up count, down interface name, right? And unique assigned IPs, right? And that is what I've got here. Total interfaces, up count, down interfaces, gigabit Ethernet 01 was down, and how many unique IP addresses is. You see, this is a list and this is a dictionary. This is a set. Okay. So this curly brackets are used both for set and dictionary. Okay. But just in dictionary, it will be key value pair. In set, it won't be a key value pair. It will just be a set of values. Okay. So this is how we used functions. Also, we have used multiple type of data structures also in the which we learned in session 2, which we have used most of that in our problem statement. Okay. Now, moving ahead with our discussion for today, right, where we'll be discussing on files, right, JSON, right, YAML, and regex, and one project. Okay, like same problem statement, which we'll be discussing in uh, next session. Okay, problem we'll be discussing now and solution in the next session. Now, why this module is important, right? Because most of our data is stored somewhere, right? Either it is stored on the device, right? Uh, Device as in the configuration on the device, right? We want to get any data from the device for interface data, right? Anything live, right? We have to take it from the device, right? So for that, we will either have some REST API, right? Some RESTConf, NetConf, or maybe platform specific APIs like Nexus API, right? Meraki API, correct? Other vendors, Juniper or Istra, they also provide similar APIs which through which we can get the data, right? Or we run some show command on the device, right? So if you are running show command on the device, then we need regex, right, to parse that data, correct? Otherwise, you might have stored that device configs or everything. Maybe you have some kind of controller, right, which takes the device configs and stores it in for some log file or in a text file, right, somewhere. If you want to get it from there, then also you need to know how to read that file, right? Or you have an inventory, right? Inventory of files, right? Maybe you are using Ansible, correct? Or you want to use Ansible later. So you will have YAML, right? So this model is important because we have to interact with some entity, right? Our entity is network devices, right? And Python is being used to interact with them, right? So our entity is a network device, and you want to get data about that network device. Now there can be multiple ways to get that data, right? Either you have backed it up somewhere, you get it directly from the device through show command, you get it through some API, right? Or there can be end type of ways, right? You can use it through Ansible, correct? Doing any of these things, interacting with the data, requires knowledge of this module, right? Where you have to understand how to work with device, files on the disk, JSON, YAML, and regex. Okay, these are the main topics we'll be discussing in this session. Okay, so let's discuss about the file, right? So file input output. Okay, now first thing is how to open a file, right? And why are we use why we if you see here, right, how we are opening a file, right? For example, config text. This is my text. Okay, this is my configuration. Okay, and now I want to store it in some configuration file, right? So what I'm doing with open this configuration file name, I want to open it in write mode. I will talk what are the different type of mode as file f, and then I do f dot write, right? But why do I need this with, right? So uh, let's see, open is it gives you a file object, okay? So with open, you are basically creating an object, okay? So it is like a handle, okay? So it will you don't have to directly interact with the what you can say, the operating system, right? So for example, you have to open any file, you have to close any file, right? You have to read file, you have to write in the file, anything, right? You have to interact with some operating system, right? Underlying operating system. So your this open will help you to do that, okay? But with is a context, right? So in if you write with, right, then after this statement is done, right, after anything within that with is done, right, this indentation is done, with will close the file, okay? What will happen is, if you don't write it in if and directly do open this and then f dot write, correct? What will happen is, if you don't close, there is a function to close the that file handler manually also, right? F dot close, something like that, right? But if you don't do it, right, or maybe if you are opening the file, closing the file, opening the file, closing the file without properly understanding where I have closed it and where I have opened it, right? What will happen eventually, that file can get corrupted, okay? Or maybe if you are running two different programs at the same time, which are using that same file, right? There can be conflict, okay? Or if you don't close the one file through this one program, other program cannot access that file anytime, right? So there are some things which can cause that runtime or you know, errors, okay, with the files. So to prevent that, right, to properly close that file, okay, even if there is some error, right, even if you forgot to close it manually, right? Manual isn't through the code itself, right, but through a manual command, right? F dot something, okay? Then with in under the with context, after this is my, like, this is like a if statement, right? After this if with statement, under it, whatever you do, okay, under this, after whatever you have done, once this with statement closes, your file also get closed, okay? So whenever you are working with any file, try to use with and then open that file, okay? So here we are reading that file. Okay, so here this is how we read the file. Here we have written in that file. Okay, so with W open course, so this same file name, right? But here you're seeing it is W. That means write. Here it is R, right? That means read. Okay, so here I am reading the file. Here I was writing the file, writing in the file. Okay, same file name is same, right? And I'm doing content f dot read. Okay, but f dot read, right, is like it will read the entire file. Okay, it is not good for maybe if you have a very big file, right? Maybe file is in a big MB file or a big GB file, right? The file is in GBs, so you cannot you can if you use f dot read, right, it will read the whole file and store it in memory, okay, which will become very heavy on the memory. It will make it very slow also, right? So I will show you how to do it in a better manner below, right? But um, understand that we are using R here. Okay, so R means it is reading. Okay, and if you see here, it printed the content, but f dot closed, right? F dot closed will give you whether my file was closed or not. Okay, so you see, when I print f dot closed, it says that file was actually closed. Okay, at this says that if I am doing any context, if I'm doing any work under with, right? After the with is closed, actually the file is closed. Okay, the file is not kept open. Okay, now compare that to this manual way, right? I have opened the file. Okay, the same thing which I did above is I'm doing below also, right? I opened that file, I read the content, then I'm closing the file. Okay, but suppose you are writing a lot of things here, right? Suppose you write your logic, right? After reading this f dot read, right? After reading this content file, you are doing a lot of work uh, on that content. Okay, maybe you are parsing that content, doing anything, right? After that, in that process, right, suppose there is an exception, okay, and after that exception, we know that in Python, whenever an exception occurs, that parsing is stopped there and itself, right? The Python interpreter will not move ahead and run f dot close. Okay, it will just stop that function. It will stop that parsing there itself, interpretation there itself, right? Now suppose say the your code never reaches this f dot close, right? then that means your file is left open. Means that pointer towards that file is left open here, right? And it can happen that any other program, same Python program in your program, in your same operating system is trying to access the same file. It might not be able to access it, saying that this file is already open in another program. Okay, or it may get corrupted. Okay, so better way is a proper way to handle it is um, using with, right? If anything happens, any error happens inside this block, right? Even before closing that error, do you handling that error, with will close the file uh, 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 point. Okay, so this is always a better way to use with, and generally you will see everywhere being used like this only. Okay, in all the code logics. Okay, this is not better way to do it. Okay. Now, as I was saying, right, f dot read will read the whole file. Okay, it is good for small files, right? Or you need the entire file contents at once, right? F dot read line is better. Okay, if you need it line by line. Okay. Now, if it is a very big file, it's better if you read it line by line rather than reading the whole file, right? Because then in memory you can store that much amount of small amount of uh, content only, right? You don't need to store the entire GB or MB bigger file in the memory, right? And then you can iterate over for line in F, right? You can iterate over lines at a time, right? And it will help you to if it's large file, right? Either you do first thing or either you do the second line. Okay, any one of them is fine. Okay. I see if it is a big file, f dot read will load all the 500 MB in the RAM, right? And iterating line by line is a better way, right? Because in the memory, in your memory, right, uh, it will store only that amount, a small amount of uh, file size. Okay, so I'm using again with only, right? You use any way of handling, right, the file, but we use it always with. Okay, with open, I'm using read, right? For line number, line in enumerate f dot start. Okay, enumerate is basically give you that line by line. Okay, so I'm taking the line by line and I'm taking the line number also. Okay, so I have done line dot r strip. Okay, that means, and the at the end in the line there will be a backslash in, right? Because in Python this is the notion that the next line has there is a new line. Okay, so I'm stripping that. Okay, and then I'm just doing some work on that line. Okay, but basically it shows that I can read the file line by line also. Okay, and it is actually better and safer, right, for big files. Now modes in which I can open the file, right? I can use R, which is default. Okay, if the file does not exist, it will throw an error. Okay, so if for reading a file, the file should exist, right? So if the file is not there, then it will throw an error, right? W is write, right? So if there is already a file present, it will overwrite that file, right? And if there is no file, it will create a new file. If you add a, right? If there is already a file present on your system, right, it will append it at the end of that file. It will open that file, append, right? Don't not overwrite. So difference between W and A is overwrite and append. Okay, and X is create errors if the file already exists. Okay, uh, this is used for creating a file basically. Okay, so if you don't want to read, write, or say append, you just want to create a file, this is what you can use it, right? But if the file is already existing, it will throw an error. Okay, now there is an important distinction between W and A, right? And it is very important. Okay, uh, in some of the things you want to use W, in somewhere you want to use A. Okay, in many use cases. Okay, for example, I have this, right? I have opened change log, right? And in the right, correct, W, I wrote something, then I used append A, right? And then I again wrote that in the same file. You see, it appended it at the end of that file, right? It did not overwrite that file. Okay. Now suppose you again open this with open changelog.txt in write mode, correct? It will overwrite this file. So your initial whatever you have written will be lost. So it's important that in log files, syslog files, and everywhere, right? If you want to log using this Python, you use the correct uh, correct format to open the file. Okay. Now, next thing is about pathlib, right? So whenever you are want to open a file, right, or write into a file, you have to give the in your that file is actually existing on disk, right, in some operating system on some disk, right, and in some so you know that disk is in disk actually will have some files, right? In some file, all this data will be stored, correct? And that file will be in a particular location on that disk. Right? So, for example, in Windows, you will have C, right? C users or somewhere, right? C users and then your username and then your say your configuration file, right? So you need that whole path, right? But if you do write the path manually, correct? Then that can have errors, right? Because different operating systems use different way to write paths. For example, in Windows, we use this slash, right, to show the path, right, to the next path. But in Linux and Mac, we use this, right? Suppose we are using Windows format, right, and if we want to open it in Mac, it won't work, right? It won't port properly between operating system. Okay, so if you want that your code should be actually can run on any type of operating system, you use path.lib. Okay, pathlib.path. This will give you a clear way to write these paths so that you can use it on any kind of operating system. Okay, so for example, I have opened from pathlib import path, right? I'm using creating a backup directory with path backups. Okay, backup.mkdir exist. Okay, true. That means I'm creating a directory. Okay, and I'm saying if there is an already directory present, then don't error. Okay, then I'm creating a backup file when I'm adding the backup dir and then I'm adding this slash. Okay, so you will be thinking this is Mac specific. Okay, so no, it is not Mac specific. Okay, this is OS safe. Okay, you don't need to do backup dir plus course sw backup.chg. Okay, this is a string, but you don't need to add it. Okay, because adding it will make it will not make it OS safe. Okay, so you directly use this. Your uh, Python code will make it safe as per a different OS. Okay, now backup file dot write text config text. Okay, basically you can open this, write, and then close it. Okay, so now I'm doing a couple of different things. Okay, but the important thing is that here I'm using pathlib. Okay, and this pathlib will help you in such a manner that if you use the same code on different operating systems, okay, it will handle the paths for you. Now this was uh, basically how to read write file. Okay, append to a file. Okay, next is we'll talk about JSON. Okay, so JSON and YAML, these are two type of text formats. Okay, one more is of XML, right? But we'll not be discussing XML here. A text format, basically, it means that this is a kind of contract. Okay, so um, you have some device, right? So suppose whenever we are talking about APIs, right? So API is what? API is a contract. Okay, it is a contract between the programming language and that device, right? That if you send me the data in this format, right, through this API, I will be able to parse it, right? So if your device can give you the data in JSON format, right, you don't have to do all the regex and everything to parse that data, right? And that is a kind of contract. Okay, so if you send the data in JSON, then your device also knows that anybody who is requesting this data will be able to parse it properly. Okay, so JSON is just like a data format. Okay, your that data format will be understanding by your Python programming language also, right? And your device also can understand that. So that is just the whole purpose of these data formats. Okay, and your data will be structured. Okay, and this JSON, we were talking about two things, JSON and YAML, but JSON primarily is the universal language for REST APIs. Okay, whenever you are running Meraki, RESTConf, NX API, NXS API, anything, right? JSON is the go-to way to do that. Okay, so you'll get the data whenever you are assume that whenever you are calling the at least in 95% time, whenever you are calling any API, the data which will return back will be in JSON. Okay, or at least there will be an option to get the data back in JSON format. Okay, now uh, JSON and your Python will be very close to each other. Okay, for example, in JSON you will have an object which will be closely correlating to dictionary. In JSON you will have an array, like this, opening, closing brackets, right? Focus on the brackets. In Python, it will be easily converted to list. You will have string in JSON, string in Python. You will have number in JSON, integer and float in Python. You will have true, false in JSON, true, false in Python. You will have null in JSON, null in Python. So it is very easy that you can convert a JSON into dictionary, right? And then start using the dictionary directly in Python, right? For example, I have this JSON file. I'm importing JSON. Okay, import JSON. JSON is the library, right, which is used to read write JSON files. Okay, or JSON data basically in Python. So I have this dictionary, right? So you see, I have JSON.dumps. Okay, I am dumping this data in a JSON file. Okay, in the JSON format. Okay, so this is JSON dump. So basically, I can convert any dictionary into JSON and then any JSON back to dictionary. Okay, so dumps JSON.dumps will convert any dictionary into or any proper Python object into a JSON. Okay, so this is my value. I have converted into device facts and indent equal to 2. So like we have indentation in Python, similarly we have indentation in JSON also. Okay, so I'm saying you use two indentations basically. Okay, and I'm saying print JSON string. So you can see this is converted into JSON. Okay, little bit different than Python, but almost same only. For example, you see here in none, here it is converted to null. Here it is capital T, here it is small t. Anyways, it's not uh, it closely relates one to one, okay, with Python, data structures. Okay, so we have converted our dictionary into a JSON string. Okay, now same we can do, convert a JSON string into a dictionary also, or into a proper Python object, for example. So difference is JSON.dumps. Dumps will convert your Python object into JSON, and JSON.loads, right, will convert your uh, JSON object into a Python object. Okay, so JSON.loads, this is my API response, right? This is my JSON data. I have put it here, and see you it passed it into a dictionary, proper Python dictionary. Okay, and now you can access the data, right? If you directly want to access the JSON data, it will be difficult, right? You will have to parse it using some regex or some anything in Python, right? But if you convert it into using JSON.loads, you convert it into a Python object. It is very easy to read it and do that, right? Now there are dump versus load versus dumps and loads. Okay, so S means string. JSON.dumps and JSON.loads, right? So the S versions work with in-memory strings. Okay, the version without S work directly with an open file object. Okay, so if you have any any string which is currently in memory, right, which you have stored, right, in any object or anything, right, you can use JSON.dumps. Example, here you see I have used JSON.dumps, right, JSON.dumps and JSON.loads. Okay, I have not used JSON.load. Okay, so JSON.load and JSON.dump is for if you have any open file, right? With that means if you have any file object, right, you can use JSON.dump, JSON.load. If you have any in-memory string, in memory, though you have not stored it in any file or anything, right, you can do JSON.dumps and JSON.loads. Okay, so that is the difference. Okay, see here what I have done is import JSON. I have opened the file in the write mode, and I am dumping that JSON data, right? And then I'm loading that data in the read mode, right? So write is closely is related to dump and read is related to load, right? Simple. But here I'm using files, therefore I'm using dump and load, not dumps and loads. Okay, dumps and loads I've used above because the data was in memory. Okay, I have not stored it in any disk or any file. Okay. Now, important point is not everything is can be converted to JSON. Okay, in Python. So you cannot convert a set, okay, into a valid JSON. Okay, it will throw an error to you. But you can convert a tuple into JSON. So you know that we can convert. I showed you, right, all what all can be converted into JSON. So this all Python things can be converted to JSON. Okay, but apart from this, uh, you still have set and you still have a tuple, right? So set you cannot convert into JSON. A tuple you can convert, but tuple will get converted into a list. And when you convert that JSON back to Python dictionary, Python object, it will not give you a tuple. Okay, so just mentioning it so that we understand that avoid converting these data types into JSON. Okay, for example, here I have JSON. This is a set. Okay, this is a set, right? And I try to dump it. Okay, it will throw me an error. Object of type set is not JSON serializable. Okay, so avoid doing it. Okay, it might throw errors to us. Okay, and I don't think many a times you'll be using it to convert it into JSON. Okay, but this is just important gotchas which we want to remember. Okay, now there is one important thing is whenever you are hitting any API, right, it will give you back the data. Okay, but it is not always sure that the data will be 100%, you can say, as expected, right? So some say some there was an error, right? Or you were hitting the JSON, you were hitting the API request, right? And in the middle, right, there was some network error and you could not complete that request, right? So you will get only half data, half JSON, right? And you know that in JSON, I have this opening and closing brackets, right? All these opening and closing brackets, right? Suppose I got the data only till here, right? This is not a valid JSON, right? Because or you can see here, right? In the first one is a valid JSON, but second one, right? I got only half data, right? So I say connection dropped in middle, right? So I only got the data till here, right? But there is no closing brackets. There is only a key. There is no value, right? So this kind of data will not be this is a malformed JSON. This is not a correct JSON. Okay. But whenever you are loading it in the JSON in Python, it will throw an error. Okay. So that error can be catched with JSON decode error. Okay. So you can do for I response, right? What I'm doing is I'm loading it, right? And if I'm loading it, I am while loading, if I get this error, right, JSON decode error, I will say it failed to pass. For example, first one it passed, right? Device one, device zero, it passed, right? Because it is a proper JSON, correct? But it not pass here because this is not a proper JSON. There is no opening, closing brackets, nothing, right? So it is empty. And here also it is not a proper JSON. So again, it failed. Okay. So what you can do is if suppose say it failed, you can try again that API request, right? So that way you can handle that request. But remember that. Uh, so why are we using try and accept here, right? Because if you don't use try and accept, your program will fail there, right? For example, suppose I am running my parsing on first one, right? It passed. If I'm running the parsing on second one, if it failed, it will just my Python code will just exit here. Okay. It will not run the third line. It will not run for third line. But if I am handling it properly, gracefully, right? I can print what went wrong with it and then go ahead and move and do the next line. Okay. So therefore, this try and accept is very important. Okay. Whatever you write under try, okay, and then you catch all the errors in accept, okay, you are preventing your whole code from collapsing. Okay, if there is an error, you are printing that error and then going ahead. Okay, rather than waiting for your entire code. Okay, so this is how to deal with JSON, right? Then next data format is YAML. Okay, YAML will be used for mostly for uh, uh, when you are what you can say mostly you'll be reading from YAML files. Okay, YAML will be you will not generate YAMLs. Okay, but you will read from YAML. Okay, reading means say you will have some device inventory, right? Config files, right? You can read it. Mostly it will be stored in YAML config files. Mostly device inventory, right? For example, in Ansible playbooks, right? Your device inventory is stored in YAML format, right? So YAML is more human readable than JSON, okay? Because there is no braces, no comma, okay? Comment is allowed, okay? But like Python, indentation is very important in YAML, okay? Everything is indented here, okay? And there are a few things which are only present in YAML, okay? Which are not present in JSON, okay? So this is how your YAML will look, right? So see you there is no opening bracket, closing brackets, right? So this is my root, right? And after that, I have given this indentation of 2, correct? And this is my again key value. It is same like JSON only key value pairs, right? But a little bit different way of representing the same kind of data. Okay. Uh, Here you See the above we were using the library called as JSON. Here we are using the library called as YAML. Okay, so there are different libraries for working with different type of data formats, right? And here above we were using loads and dumps, right? Here we are using safe load. Okay, so here also we'll have load and safe load. Okay, but safe load is a better way to do it. We'll talk why, right? And you see I am converting it, basically it is converted into a dictionary and I'm printing the in a dictionary, right? Now YAML will have safe load versus load. Okay, now uh, in YAML, with YAML there are some security concerns. Okay, so what can happen is um, uh, we somebody can inject some Python objects, okay, in the YAML file. Okay, some malicious in some malicious YAML file. Okay, if you directly load that YAML file, okay, it can run that malicious part of code. Okay, just remember that it is a security concern. Okay, so better to use YAML.saveload. Okay, most by default use YAML.saveload. Okay, if it is due to some reason it is not working, or it is failing, or it is uh, there is a what you can say hard and fast rule that you cannot use safe load, which it will not be there. Okay, then only use normal load. Okay, otherwise make it a practice that every time use safe load. Okay, plus if you don't have the control of from where the data is coming, right? So definitely use safe load. Okay, it is better. Now how to write back in the in YAML, right? I read, we understood safe load, right? Write is dump, same like JSON, right? So this is dump. Okay, this is my Python data, right? And I am dumping it. Okay, sort keys is false, right? And default flow style is false. Okay, then again I am reading it using then I am one way is doing this, and the better way, as I told, right? Always we use with, right? And this is writing it in a file. Okay, I'm writing it in this list file. Okay, this is just in memory, this is just a string, okay, in the memory. But if you want to store it in a file, this is the way to do it. Always use with, okay, to store it in a file. Now JSON and YAML, what is the difference? When to use JSON, when to use YAML, right? When to uh, it falls down to what you are doing. Okay, all these are used, all these differences I've mentioned, right? But normally and 95% of the time you will be using JSON to talk with a API, right? And YAML will be used in a, if it is a human readable file, but your code has to use it. For example, there is device inventory, right, which a human might also have to edit, right? It might be present in YAML format, which your code also will read, right? Or there are some configurations which some user also has to edit, right? So that can be present in YAML format, which your code can also read. Okay, but if you're talking with some device, right, wherein no there is no human to write and read in that, then JSON is the go-to thing. Okay, but JSON is a little bit complex because there are, if you miss a comma, if you miss a opening bracket, closing bracket, it will become non-readable by your code. Okay, so that is why there is a little bit difference between JSON and YAML. Otherwise the format they represent, okay, the data they represent is almost identical. Okay, next is regular expressions, right? And I would say this is a most important part, okay, to understand. We'll not be discussing everything about regular expressions. Okay, regular expressions itself is a big construct, big topic to discuss, takes a lot of time, right? So we'll not be discussing everything about it, but I'll be giving a good idea, a beginning, right? So that you can build on it later. Okay, but understanding regular expressions is very important because many a times we will not be using API, and for say monitoring or many other purposes, right, we'll be using direct show commands on the device, right? Because that has the live data, correct? We can use show command. We will be using syslogs, right, which will be stored in some syslog files, correct? We'll be reading from that. We'll be reading config lines, right? And these all are unstructured data. These are not stored in some JSON or YAML, which we can easily convert into a dictionary, right? So this is basically regex can be used to search and extract particular things from a string, basically. Okay, whenever we're opening a file and reading it from that file, basically it is a string. Okay, So how to get the specific data? For example, interface G has IP address with MAC this, right? Now I want to get the IP address from this, okay, from this line. Okay, what I can do is I can do RE. Yeah. So import RE. RE is my uh, uh, module, okay, which I can use to interact with regular expressions. Okay, so import RE, right? And I have a function called as re.search. Okay, re.search will give me the first match. Okay, so what I'm doing is I am doing R, right? R is for that means this is a regex pattern basically. Okay, and this is my regex. Okay, I'll talk about what does plus this slash d means and all plus and all means. Okay, but this is basically a regex pattern, and I'm giving the this text in this regex, and I'm saying if you find this regex pattern in this text, give me the first instance. Okay, so you saw that I'm giving this is the first instance. Okay, 192.168. Okay, so this is how I'm using regex. So slash d means any digit. Okay, you want to match any digit between 0 to 9. Okay, any digit you want to match, you can use slash d. Slash w to match any word. Okay, word means letter, digits, underscore. Okay, slash small s. Okay, all these are small letters. Okay, so slash s means any white space you want to match. Okay, dot means match any character. Okay, except new line. Plus means one or more of the previous thing. That means one or more of the iteration of the previous thing. Star means zero or more iterations. Question mark means zero or one iterations. Okay, so what I've done here is slash d means I want a number. Okay, I want any number, any digit. Okay, which should occur one or more times. Plus means one or more, right? So I want any digit which is present one or more times. Then I want a dot, right? Any a dot, right? When I'm attaching it with backslash, that means I don't want to use it as a regex. Okay, I want a literal dot. Okay, then again I want a number, more than one number, right? And again a dot, more than one number, again dot. This basically shows that I want 4 octets. Okay, and in each octet there should be at least one number. Okay, this is not an ideal way to match IP address. Okay, very loose way to match an IP address, but this is how it's a basic example, right? So you can create more complex. Okay, I will talk about more complex way to match IP below, right? But for that, you need to understand a couple of more things. Okay, uh, bracket, and in bracket n comma m means I want a between n to m repetitions. Okay, these brackets, square brackets means I want any one of these character from this set. Okay, to match. Okay, then this sign means starting with, and this line, this dollar means ending with. Okay, this means round brackets means a group, and this means an or. Okay, so for example, now below what I'm doing is I'm saying I want a digit, and that digit should be 1 to 3 digit long. Okay, so you know that at max an IP address can be 255, right? So at max it will be 3 digit long, right? Then I need a dot. Again a digit 1 to 3 long. Again a digit 1 to 3 long, right? Again a digit 1 to 3 digit long. Okay, so basically I'm saying I need 4 octets, and in each octet there should be no more than 3 digits and no less than 1 digit. Okay, so this is a more strict way, a proper bound IP pattern. Okay, now you can group part of pattern in this, right? And this is for that you match, you want only one piece, right, of some named entity. Okay, so here for example, right, I am saying August 15, this is my say some syslog, right? I am saying this is my month will be word, right? This is a word slash w plus. Okay, a group of words. Okay, then some space, right? Then I need a group of numbers, then again space, then I need the time in this format. Okay, I'm not discussing every bit and piece, right? It is you can take a look from the table I showed above, right? But this is what I'm saying, that I want this thing as a month. Okay, so then I can say match.group interface, right? So when I say match.group interface, I want this interface. Okay, so therefore it gave me gigabit ethernet, right? And I want to match state. So I got this state. Okay. I want month, day, time, right? So this is my group, and this is the way how to match in that. Okay. This is the group. I want a digit group. This is time. That time should be in this format. This is the host name. This should be in this format, right? So I'm saying the group name and in the what format I need that data. Okay. Then I can use re.sub. Sub is for search and replace. Okay. You want to search some pattern, then you want to replace it with something. Okay. For example, you want that if in my data there is 10 gigabit Ethernet, I want to replace 10 gigabit Ethernet with T. So for example, here it will be 10 gigabit Ethernet. Okay. It will not match anything else because it says that I want to start, right? This is start. This symbol means start. If any string starts with 10 gigabit Ethernet, replace it with T. So this will be replaced with T. If any string starts with this gigabit Ethernet, replace it with GI. So it will replace it with GI. Right? So you can see it formed it. Correct. Now match, right? Match will match only the first start of the string, any first string. Okay. Search, match versus search. Search means it can be anywhere. Okay, not in the very first. Okay. Then find all, you can match all the matches. Okay, there is it is not like I want only the first iteration. You can match any number, right? And find it at uh, you want to you want all the matches, right? But you want it in a group, right? For example, you have a very big text, right? So you want to use find iter there. Okay, and it will match it on specific groups, right? We use saw above, right? It made group of that object. Now, one important thing is greedy versus non-greedy. Okay. So we have two, right? Star, plus, and plus, right? Star means zero or more. One means at least one or more, right? And these are greedy by default. Okay. Uh, but if you add a question mark after them, they become non-greedy. Okay. So for example, let's talk about what does greedy and non-greedy means. Okay. So for example, I have this description uplink to core backup link, right? And I have told that I want between an opening and closing brackets, I want whatever text you can capture, right? So this is greedy. Greedy means it saw this opening bracket, okay? It captured this much text, okay? But there is a closing bracket here, right? So it should have stopped, right? But it is not stopping. It is greedy. It is looking, do I have any more such matching patterns? Okay. So you see one pattern is this closing and opening and closing, right? And one pattern is this opening and closing, right? Here also there is an opening bracket, closing, right? So the if you don't put question mark, it will greedily take all this text. Okay. Try to have as much text as possible, but matching your condition. Okay. So it matches from the first quote to the last quote. Okay. But this matches, if you put question mark, it matches just from the first quote to the next quote. This much. It is not non-greedy. Okay. So this is an important aspect, greedy versus non-greedy. Okay. Validating input. Okay. Same thing which we talked about right now, right? Uh, just I've added a start and end, right? So that it is more strict, correct? So this is a start. Anything which is starting with a number, one or more one to three times, then a dot, number again, 1 2 3 long, again dot, right? So it says that I need 4 octets, only 4 octets, no more than 4 octets. But within each octet, there should be a number which is 1 to 3 digit long. Okay. And that will give me all the IP addresses, right? But there are some limitations to regex. Writing regex can be very complex. Okay. If you have a way to get data from JSON or YAML, use it. Okay. Don't use regex. Okay. But if you have to use regex, okay, so for example, in some CLI output using some, or you want to use by default, maybe for example, or your device maybe don't have API for everything, right? So then you have to run show output on your device, right? Or you are reading some log file, correct? There you won't have any API. So there you have to by default read that log file and use regex. Okay. So whenever you are doing that, if your use case is very small, you can use regex. Okay. But if the use case is very big, use some parsing library. Okay, like TextFSM is one of the good parsing library which I have used. Okay, I have not used NTC, but it is also good. Okay, but TextFSM in itself provides a very a good uh, power, right, which you don't get directly with regex. Okay, once you start using it, you will understand the benefits of using text fsm. Okay, but it is like a library for regex. Okay, you still have to write regex. Okay, but some of the complex pieces of regex, okay, or working with regex on big files or on big on proper deconstructed data, right, it makes your life a little bit more easier. 50%, 60%, it makes it easier to interact with the data if you're using some kind of regex library like text fsm. Okay, now we have discussed all of the things in this session 3, okay, about files, right, how to read and write to files. We talked about JSON, YAML, okay, and then we talked about regex. Okay, so I'll be leaving you with a problem statement. Okay, again, like every time, we'll be discussing the problem statement now, but solution will be discussed in the next session. Okay, so this time you have to parse a raw syslog file end to end. Okay, this is my raw syslog file, right? I have written it to a file, right, this file, and you have this inventory file, right, that also I have written to this file. Okay, you understand what are the file names, correct? So I've created the files already for you, right? You read the uh, log file. You have pulled a raw log dump from your logging server. Okay, you have a small inventory file which describe the host names are critical devices, right, which host names are critical, you have written, right? This is example course which one is critical, this is not distribution which is not critical for you. Okay, I've marked that data using this YAML. So now read the log from the disk. Okay, use regex to extract timestamp, hostname, severity level, interface, and message, right? Load the YAML inventory, determine which host names are marked as critical equal to true. Build a list of structured dictionaries, one per log event is critical device. Write the result in a JSON report to disk and print short summary, total event, how many devices from critical device, how many were severity error or was critical. Okay, so this is like a real thing which we'll be doing in production also, right? So this is my logging, right? And this logging is just one file from multiple devices. So for example, some logs are from course which one, access, distribution, right? So I want that uh, from this raw log, you find it out which on which uh, high critical devices, what kind of logging is there. For example, on course which one there is a this is a critical, right? So on how many logs do you have on critical device, right? So that you have to find, right? So and you have to print a short summary. Okay, so that is the problem statement. Okay, and try to write the code. The code should have all the good practices which we discussed in session 1 and 2. Also try to use as much data structures as we can do, right? Try to use code it using functions, right? And use all the best practices which we discussed in this session. Also the file should be properly closable, so use with, right? Try to catch any errors which we talked about in JSON also, right? JSON decode error in inventory YAML, you use a safe load so that you are using the best mechanisms to read the file, right? And whatever safe practices, whatever we discussed today, try to incorporate it. Okay, I know that without using that also you can solve this problem statement. Okay, but that will not be the best way to write that code. Okay, so writing code is also important, but we have to write the code in the best possible way. Okay, so that it is not security is not a main concern here, right? But if there is a security concern which is known to us, right, that if we do it this way, then my program will behave in some different way, right? Then we should try to solve that while writing the program itself. Okay, so this solution we'll discuss in the next session. Okay, and till then, thank you for watching this session. Thanks.